All right, in section 5.4, we are going to be doing sum and difference formulas and reviewing how to expand the formulas out and to evaluate. Let's go ahead and look at our first example. Prior to looking at our first example, though, you might want to pause the video and write down these formulas. These are the sum and difference formulas for each of sine, cosine, and tangent. All right, here's what we've got. So find the exact values of each of these. So sine 15, we would actually find it by doing sine of maybe like 45 minus 30. You can do either 60 minus 45, but you do need to make sure that you use the angles from the unit circle. And then we would take and do sine of the first angle, 45, times cosine of the second angle, 30, minus cosine of the first angle, 45, times sine of the second angle, which is 30. All right, we've got sine of 45 from the unit circle is root 2 over 2. Cosine of 30 is the root 3 over 2. Cosine 45 is root 2 over 2. And sine of 30 is a half. All right, this concludes then we've got the root 6 over 4. Because you're going to multiply these together, you're going to go ahead and do the multiplication here, and then add. So you got root 6 over 4 plus root 2 over 4, which ends up being root 6 plus the root 2 all over 4. So that's our final answer. Now this would give you the equivalent of sine 15 using degrees in your calculator. So that would be the decimal equivalent. Let's go ahead and now look at what we would do for cosine. So cosine would be cosine of 45 minus 30. Again, you could use 60 and 30 or 60 and 45. Either way. This is cosine of 45 times cosine 30 plus, using the formula, so you have to change it, that's addition, sine 45 sine 30. All right, this gives us, let's see, root 2 over 2 times 1/2 plus sine 45 is root 2 over 2, and sine 30 is, cosine 30 was root 3 over 2. Sine 30 here would be would be 1/2. Multiply first, you get the root 6 over 4 plus right here we've got root 2 over 4. Final answer, root 6 plus the root 2 all over 4. And I'm just noticing as I'm finishing this answer that up here I had subtraction and I copied over here addition. So this is subtraction up on that first example. That should have been subtraction. You probably had subtraction. I copied over addition. All right, tangent. Tangent of the angle. You don't want to use tangent 30 unless you absolutely have to because of the root 3 over 3. So I'm actually going to use 60 and 45 on this one. My formula would be tangent of 60 minus tangent of 45 over 1 plus the product of tangent 60, tangent 45. Final answer, you get tangent of 60, which is root 3, minus 1, tangent 45, over 1 plus root 3. Well, you can't leave your answer like this. So what we have to do is we have to multiply by the conjugate. The conjugate would be 1 minus the root 3. So top and bottom, multiply by the conjugate. That would be foiling the top, foiling the bottom, and then doing common term work and simplifying. All right, so it looks like this. We would have the square root of 3 times 1, which is the square root of 3. The square root of 3 times negative square root of 3 is minus 3. Negative 1 times 1 is minus 1. And negative 1 times the root 3 is plus the root 3. That's the top. On bottom, the middle terms are going to cancel. 1 times 1, and then you have 1 times negative root 3, and plus 1 times the root 3, which is root 3, and then minus 3. Square root of 3 times itself. This finally equals negative 4 plus 2 square roots of 3 all over 1 minus 3, which is negative 2. Final answer, this is negative 2 minus the root of 3. So there's the final answer for the tangent. All right, so those are the 3 solutions there for this last example. Okay, that just gives you a good review of what the formulas are like, and now we're going to use them a little bit. All right, example 2, it says find the exact value of cosine of v minus u. So you can use any letters, any variables for your angles. Given the sine is 5/13 and cosine of v is negative 3/5, u and v are in quadrant 2. All right, let's put our angle of u here in quadrant 2. This is going to be angle u. And we're going to put angle v here in quadrant 2. I basically make the triangle here, and we'll label the sides. So u, the sine is 5/13, so that's 5 to 13, which makes my x a negative 12 using the Pythagorean theorem or your Pythagorean triples. There's a right triangle there. And v, the cosine is negative 3 to 5. There's negative 3, 5. That makes the y value 4. All right, so here's what we would do. We are going to expand out. So you've got cosine of v, cosine of u, plus sine of v, sine of u. And we're going to substitute. So cosine of v is negative 3/5 times cosine of u is negative 12/13 plus sine of v is 4/5. I'm going up to my triangles, and I'm doing the sine of v. And now sine of u, I'm going up to my triangle, and that's 5/13. Negative 3 times negative 12, that's 36/65 plus 20/65 equals 56/65. That's your answer. Approximating decimal is 0.86. All right, we've got example 3. Find the solutions of the equations in interval between 0 to 2 pi. You can use a graphing utility to verify that. So cosine of x plus pi over 4. What I'm going to do is up here I'm going to go ahead and expand this out. Cosine of x, cosine pi over 4, minus sine x, sine pi over 4. Expand that out. Now I'm subtracting the same thing here, cosine of x, cosine pi over 4, plus sine x, sine pi over 4, but equals 1. What I noticed here is because I'm subtracting, here I'll show you what happens when we apply the subtraction. So I'm going to add the opposite here, and what happens is I've got my cosine x, cosine pi over 4. They are actually going to cancel. I've got this cancels out with this one. They're opposites. So that leaves me with a negative 2 sine x, sine pi over 4 equals 1. Combining my like terms there. Well, I also know that sine of pi over 4 is root 2 over 2. So it's negative 2 sine of x times the root 2 over 2 equals 1, which equals negative sine of x times root 2 equals 1.
Mr. Carlson, please dial extension 2640.
Or I can write that as negative root 2 sine of x equals 1. And I need to divide by the negative root 2 over 2, or the root 2 over 2. This is sine of x equals 1 over negative root 2. I need to rationalize that. So here's what I'm looking for. I'm looking for sine of x. When is it equal negative root 2 over 2 within the interval of 0 to 2 pi? I'm going to go back up on top here. So I need to do inverse sine of negative root 2 over 2. What are my angles? Equals x. Well, sine is negative in quadrant 3 and 4, and this would occur at the fourths angles. So my answers are 5/4 pi and 7/4 pi. Quadrant 3 and 4 is what we're looking at. Those are the final answers here to example A, right there. All right, looking at my next equation, I'm going to go ahead and copy this to another page so that we can solve this. All right, here we go. We've got, let's go ahead and expand these out. So we've got 2 times, I'm going to go sine of x, cosine of pi over 2, plus cosine of x, sine of pi over 2. And that is expanding out the sine. I'm going to expand out my tangent here now, and my tangent would be, so plus 3 times, you've got tangent of pi minus tangent of x over 1 plus their product, tangent pi, tangent x. Equals 0. All right, here I go. I've got, to simplify some of this, well, cosine of pi over 2. Cosine of pi over 2, let's go right here. This is 0, so I can cross that out. That's equal to 0. And sine of pi over 2 is 1. So here I've got 2 sine of x. Sine of x times 0 is 0. So I've got 2, that's all going to be crossed out, 2 times cosine of x plus, and let's see, tangent of pi is also 0, so that's going to be 0. I basically am left with 3 times a negative tangent of x equals 0. I'm ready to solve. I'm going to go 2 cosine of x minus 3 tangent of x equals 0. I need to write these in different forms. So 2 cosine of x minus 3 sine x over cosine x. I'm trying to get these in so that they have the same denominator. Common denominator, I would multiply the top here by cosine. So it's 2 cosine squared x minus 3 sine x all over cosine x equals 0. If my equation is equal to 0, I'm just worried about the numerator. So now I can do 2 cosine squared x minus 3 sine x, and I can just set that equal to 0. I do not need to worry about my denominator. I need to write this cosine squared in terms of sine, so 2 times 1 minus sine squared x minus 3 sine x. Set that equal to 0. I'm going to go ahead and put all of this in the right form here. We've got 2 minus 2 sine squared x minus 3 sine x equals 0. I'm going to rewrite this and also divide by a negative, all in the same step, or I can just move everything to the right side. 0 equals 2 sine squared x plus 3 sine x minus 2 equals 0, or just the minus 2. All right, I'm going to go ahead and copy this to the next page and go ahead and factor this, and so that we can continue to solve. I've got 2 sine squared x plus 3 sine x minus 2 equals 0. This factors to 2 sine x 2 sine x, let's go plus, let's try getting our signs organized here. Sine x here, I've got to have a middle term of 3, and my signs have to be one of each. So I'm going to go plus 2 here and minus 1. Set it equal to 0. So when does sine x equal 1/2, and when does sine x equal a -2? That's what we're asking ourselves. Well, sine x cannot equal a -2. That comes back from sine only goes, the domain of it, or the value of it only goes from -1 to +1. So this part's no solution. So when is sine equal to 1/2? Well, that happens at quadrant 1, pi/6, and quadrant 2, 5/6 pi. So those are the solutions. All right, here is your assignment for this section 5-4. That's your assignment.